All right, here we go. Let me have your attention up here. Like I said, guys, I'll post this. I'll post this in the middle of my webpage. And what I would suggest that you do, guys, is you look at the other classes stuff. Okay, I'll work through these in this class, and we'll have some of the other ones that we work. The first one, it's expanding logarithms. The number one here says log 3 later 4x squared. Okay, how many things do you have to move, or how many things do you have to logs do you have to end up with? 2. How do you know this? There are two parts to this thing. So I know, guys, I'm going to expand that and go to the log base 3 of 4 plus the log base 3 of x squared. Again, some of you are struggling with this because the log base 3, but remember, if it's not, guys, if it's not the log base 3, it's not numbers that you're going to be dealing with anyway. So then, every time I have an exponent here, I take that exponent and I write it down in front. So it's log base 3 of 4 plus 2 times log base 3 of x. Yesterday, guys, the big deal was I asked y'all as a warm-up exercise, I wanted to know the log of 100. And a lot of you guys were very comfortable with saying that the log of 100 was 2. Thought that was good. So I changed the log of 100 to the log of 10 squared. Guys, that's this. That was a 10 squared, guys. You take that 2, bring it down in front, and that becomes 2 times the log of 10. Well, what is the log of 10? 1. So this is 2 times 1. Guys, it works. This stuff that we're doing, this logarithm things that we're trying to get done, guys, they work. Again, this could just as easily be the log base 3 of 36. And if you take numbers like 4 times 9 right there, 9 is 4 times 9, 9 is 3 squared, so that would be log of 36 is equal to 4 times log of 3 to the 4th plus 2 times the log of 3. And guys, if you did that, it would work out. Again, if this was 4, this was 3, it would be the same thing as the log base 3 of 36. Again, the way you'd figure that out is you'd say the log of 36 divided by the log of 3. And that's expansion. I'll work 2 and 3 on another video. Look at number 4. Guys, number 4 says the log of a plus 4 times the log of a minus log of 12. The biggest mistake that people make with this stuff is they don't apply those rules that we talked about. And the rules said that those are all numerators. So it's going to be written under 1 log. So that's a, and a to the 4th is a times a to the 4th is a to the 5th. And this minus 12 means that goes in the denominator of that. It means it's divided by 12. Okay, and then a to the 4th times 8, guys. This inside that parentheses, there's a little cocoon right there that protects all. Just do that math right there. Is do that a to the 5th over 12. Log base a to the 5th over 12. You work it out. Anybody? All right, number 7, guys, number 7 says use a calculator to figure out the log 1/4 of 8. Again, the calculator is going to have to be done in a specific way because the only way these calculators work here is when you put them in as change of base. And remember, it's log of 8, there's log of 8 close the parentheses, divided by, again, this says 0.25, I wrote a fourth. The reason I wrote a fourth is because I want to make sure I show you, guys, if you mean 1/4, you have to close the parentheses around that 1/4. And so now this is the log of 8 divided by the log of 1/4. And you guys, hopefully, you'll see that you get -3/2 right there. Again, the way you get the -3/2 is you can change that to 10 to the second and go through all that process right there. But the answer is -1.5. Do I need to show anybody how to use their calculator? All right. I continue on. Guys, I'm down to number 10. Guys, like I said, in this class, I'll do some of the problems. In the other class, I'll do the other ones. So if you want to check your work tonight, right after school on my web page, I'll post these of me working them throughout the day. Again, guys, the best thing that you can do is practice this stuff. You can practice this. You can practice it. You can go back and watch my videos, kind of work through it with me. Okay, this problem isn't down to a square root on one side or an x squared. You got to work it down to a log on one side and everything else on the other. So the first thing I have to do is go 8 minus 2 is 6. And 8 minus 2 is 6. That's a plus 2, so a minus 2. So then what's next? Divide by 3. Natural log of x plus 3 equals 2. And then for, guys, right here, it's like you guys have this idea that you don't know how to do these, and so you're going to convince yourself that that's the case, when if you got this far, if you understand the logic of minus 2, why did I subtract 2? Get rid of it. Why does that get rid of it? Because what's 2 plus -2? It cancels to what? 0. Why did I divide both sides by 3? To get rid of the 3. Because what's 3 divided by 3? 1. And it gets rid of it. Guys, that's what we're doing in this stuff. The only thing that we have to add new to this chapter is understanding that natural log is base e. So when I do natural log of e to the x plus 3 equals, well, if I do that to this side, I have to do it to that side. I have to exponentiate that side. But guys, the same logic that got us down to this line right here carries us on from here on down. Okay? Because all we're doing is solving an equation. This is inverse of each other. E to the natural log of x plus 3 gives me x plus 3. That drops off of up there. So x plus 3 equals e squared. Okay, again, if I asked you, if you walked in the door right now and you looked upon this problem, everybody would go, oh, that's pretty easy. I subtract 3 from both sides. Again, why did I choose 3? So that's a plus 3. So I subtract 3 from both sides. Subtract 3 from both sides. When I do that, I end up with x equals e squared minus 3. Well, guys, you got to calculate what e squared minus 3 is. Okay, the way you calculate e squared minus 3 is you use some form of technology. The technology that we have access to is our calculators here. And so I want to use the calculator to help me get e squared minus 3. So here's e right there. There's e. So I want e squared minus 3. And then it's 4.4. So x equals 4.4. That's it. Go back up here, plug in a 4.4, and you do, it'll work. It'll work. Plug in e squared minus 3 right there. As if you plugged in 3 times natural log of e squared minus 3 for x, I can really see how that gives me 8. So that's 3 times the natural log of e squared plus 2. Come on. We did this yesterday. What's the base? E to the E. The natural log of E to the E. 1 times 2. 2 times 3 plus 2. Guys, this stuff works. It works. It's not me up here inventing some cool little things to do to give you something to do in the afternoons. Okay? The stuff that we're doing, the equations that we're working, work out. They work out a certain way. When you try to work 2e to the x equals 10, that's when you get your answer and you plug it in, it'll give you 10. So to figure out what the answer is, I divide both sides by 2 and I go e to the x equals 5. I need to get rid of something. Again, everybody in the room understands right here why I wrote divided by 2. It was to get rid of the 2. The way that gets rid of it is what is 2 divided by 2? 1. So it's gone. Okay? Here, I need to get rid of this. So to get rid of that, I take the natural log of this side. Because the natural log E of E. Yesterday, I wrote log base 5 of 5, and we were all really comfortable with writing 1. Nobody had a question. Right, I'm writing log E of E. But log E, when the base is E, is called the natural log. So, what would this leave me with? On this side, it would leave me with x. That's x. That's if this number was squared up here too. So that would leave me with x on this side. Well, if I did it to this side, what do I have to do? Do the other side. Natural log of 5. And it's this part right here that's causing trouble for us. Guys, we think that we're not good at math because the only way to figure out what the natural log of 5 is, guys, is to go to your calculator. Now, that's not necessarily true, but that's true for us because we don't have any slide rules in the room. We don't have the table in the back of our book. We think that it's because we're using some kind of technology to figure out what the natural log of 5 is that inherently we don't necessarily know what it is that we're doing. But guys, you do. Okay, the natural log of 5, I hit enter here, plug it in, 1.61. So I come here and I say x is approximately 1.61. But again, to show you what I'm talking about, 2e, I think the answer is the natural log of 5. Okay, so based on what we've logically been talking about here, this inverses each other out and you end up with 2 times 5. Well, what's 2 times 5? 10. Again, what I've been trying to get y'all to do, it works. Guys, it works. When you get the answer, natural log of 5, and take natural log of 5 and plug it back in for x, it gives you 10. Now, the answer we write is 1.61 because that's what the natural log of 5 is. Anybody? Again, I'll work through the other problems. Flip over on the back. I got an inequality here I'm going to work. I'll work through all the... I've just got marked on here certain problems to work in the certain classes. 3 to the x plus 4 greater than 20. Okay. Again, I need to get rid of 3. I need to get rid of 3, so I take the log base 3 of this side. Well, if I do it to this side, then I have to do it to that side. Log base 3 of 20. When I take the log base 3 of both sides, this answer is x plus 4 times 1, which is x plus 4, is greater than log base 3 of 20. Okay, that's plus 4 plus 1. So I minus 4 from both sides. I minus 4 from both sides. So I get x is greater than log base 3 of 20 minus 4. Right now, we're going to figure out what this is. Log base 3 of 20 minus 4. But guys, if I come back, watch this. If I come back up here and I put in that whole thing for x, that would be 3 to the log base 3 of 20 plus 4 minus 4. If that was plugged in for x, it works. Now, what we have to have is we have to have an answer for what this is. So it's the log of 20, close your parentheses, divided by the log of 3, close your parentheses, hit enter, subtract 4, and I get my answer, negative 1.27. So x is greater than negative 1.27. Again, I told you about this stuff, guys. If you go to my web page, this video, or this right here, shows you what it is that you want to write your answer as. Also, on my web page, I'm going to take this out tonight. I'll take this out, this interval notation out, and that's where I'll put the stuff right here. Okay, so just check the other. There'll be 3 playlists right there that you can check your answers on. So greater than negative 1.27 is 1.27. You do a parentheses, comma, and go to positive infinity. And again, I use parentheses because that's greater than or less than. Questions? All right, let's keep going. Second period, I'll do number 19. This is second period. During sixth period, I'll do 20. During seventh period, I'll do number 22 right now. But for y'all, I'm going to do this problem right here. So when y'all are watching it here, hopefully you've worked these, guys. Again, you guys that are just watching me work them, maybe what you can do now that you've seen this one is you do the other 2 and then check those later tonight. But guys, you got to try these without just sitting there, sitting here watching, and then going, I don't know how to do these. Of course you don't, guys. All you've done is seen them work. Okay. The first thing with this is it says write an exponential function. So you have to know, guys, you have to know that an exponential function is y equals a times b to the x. Again, y equals a times b to the x. Take these 2 numbers right here and put the one that's got the 4. Let's put a 4 in for y, guys. That's what y is. This number's x, this number's y. So I'm going to take 4 and I'm going to put right there. Equals a times b to the first. So b to the first. This is 256 equals a times b to the negative second. Okay, so now all I do is I work my problem out. Well, this works out into being 1 over 4 times 4 is 16 times 4. It looks like that's 1 over what? 64? Equals b to the first minus a negative 2. That looks like that's b to the third. So if I take the cube root of both sides, I find out b is 1/4. 4 times 4 is 16 times 4 is 64. Take the cube root of that side, take the cube root of this side, it gives me 1/4. Take that 1/4, plug it back in right here, so 4 equals a times 1/4. Again, how do I get rid of the 1/4? Times it by 4. It's 1/4 a. So times it by 4. If I times that side by 4. Guys, again, that's what I did back in those other problems. In the other problems, the way you get rid of a log is by exponentiating. The way you get rid of a base is by taking the log of both sides. So I'm doing the same concept over and over and over again. So this gives me 1a equals 16. So a is 16. Use this information right back over here. So y equals a, which is 16, times 1/4 to the x. And the biggest thing that I do that some of you guys don't do is, guys, it concerns me whether or not I'm getting these right or wrong, so I check them. Again, this stuff works. If you plug in a 1 right there, that gives me 1/4 times 16. What's 1/4 of 16? Look, 1/4. When I plug in a -2, that gives me 16. 1/4 of a -2 is 16. The negative flips it, the 2 squares it. 16 times 16 is 256. All right, skip down. Guys, skip down if you would. Again, I'm going to work different ones in different classes. Number 19. Guys, if you haven't worked 19 yet, I'll talk you through 19, and then maybe you work 20 and 21 and watch it as we go as you go through the day. So here it says you deposit $450 into an account. So my P is $450. It says it pays the interest is 5.5%. So I take 0.055. It's compounded continuously, or I guess N is that, continuously. For what period of time will you have more than $520? So T is what we don't know. So again, when it says it's compounded continuously, that means we use this formula right here. A equals P to the RT. Again, if I ask you to make a model out of this situation, guys, take out A and use what? Y. Take out T and use what? X. And just graph it. That's what I mean by a model. Plug it in there and you can see every possible solution. So now, to work it, you go 450 e to the r 0.055. X is what you're looking for, and you want to see for how long does it take us to get that amount over $520. What do I need to get rid of? 450. Divide by 450. Divide by 450. So e to the 0.055x is greater than this value right here. 520 over 52 over 45. So whatever this value is. So I'm just going to write the word value right there for a second. Whatever that is, that number goes right there. Okay. Now I need to get rid of the e, so I take the natural log of both sides. And so if I took the natural log of this side, I got to take the natural log of that value, whatever it is. How do I find that value? I divide 520 by 52 by 45. Then that gives me 0.055x is greater than whatever that number is. And I find that number again by doing that work, and I divide by 0.055. I divide by 0.055. And there's my answer. That's my answer right there. Again, I think some of you think you're supposed to be able to figure out what this is right here, and because you don't look at the natural log of 45 over 52 or 52 over 45 and know what the answer is, you don't know how to do that. Guys, you do. You can know how to do these really well. I feel like I can work these problems pretty good, and I like working these. This idea of logs and stuff is something as a mathematician I don't mind. But I know the log of 1,000 is 3. Doesn't bother me. Some of you guys are still struggling with figuring out that, and you've taken that idea of not knowing what the log of 1,000 being 3 is and applied it to I don't know how to do these everywhere. And that's not the case. Guys, what you do now is 52 over 45. So I just calculate this out. Okay, so I plug in natural log of 52 divided by 45. I take that answer right there. I figure out what it is. And then I divide it by 0.055. Well, goodness. So, natural log of 52 divided by 45 over 0.055. It's 3.04. Again, guys, that's the equation. To make a model out of it, I take all that stuff out and I just type this in here. 450 times e to the 0.055 x. What now? 520? Okay, I'll check it a second. Divided, or x. And the question is, when is it? It looks like it does right there. It's 3 years. So between 3 and 4 years, it gets over 520. Oh, between 2 and 3 years. Yeah, it should be 2.6. Yeah, my bad.
Right here. That's what you want to verify. So that's the value of the
So there's that answer. There. Sorry about that. 2.63. So it's 2.63, not the other number I have.